In quality management of food products, we not only have a quality management system that covers the entire company, but those systems give you basic quality control tools. There are 7 very commonly used quality control tools that we'll be talking about in this lecture. So the outcomes of this lecture, you'll be able to describe how to use these quality control tools when you're given a quality control problem. We'll start with Pareto charts. So you can see an example of a Pareto chart right here on the right. This is basically a ranking of data classifications in descending order from left to right. So we've got the vital few over here on the left. These are our categories that really dominate the ranking. Their bars are much larger than some of the other categories we have over here on the right, called the useful many. Then when we can't figure out a certain category to put our quality control problem in, we just put that in the other right here on the far right. So this bar, since it contains many quality control problems, may be a little bit bigger than some of our other smaller categories, but that doesn't mean that these problems are a major problem. It's just that we have a lot of them stuck together. So we can use these to kind of narrow down what do we really need to focus on, and that's the vital few. Cause and effect diagrams are a second type of quality control tool. So we use these to identify potential causes of problems. If we have a quality issue with our final product right here, what we can do is sit down and make a list of what goes on in our process. So here we have a bioprocess where we're mixing, we're fermenting, we're doing a heating step, we're filtering the product that comes out of that, we're packaging, and then we get to our final product. If our final product has a quality problem, then we need to figure out where in our process that problem is occurring. So when we make these cause and effect diagrams, we can see what goes into each step. So in the filtering step, we have a pore size that can cause a problem if our pores are too big or too small. We can have flow rate that causes a problem. If our flow rate through our filtration system is too high or too low, we may not be able to get the product that we want. And we can also have sub-causes here that can affect our primary causes. So if we think we have a problem with flow rate, we might be having a problem with flow rate because we have some fouling on our membrane. We have something building up on our membrane that's causing a lower flow than we're expecting. So this just lets us see where the problems can come from. We can also use process flow diagrams to help us out with our cause and effect diagrams. So if we go back to the cause and effect diagram, we can see that this in the center right here is our process flow. And that looks very similar to the type of flow we see here. It's a different process. This is basically a materials handling process for a food company. But it's the same sort of block diagram. And if you want to get really technical, what I'm showing you right here is a block diagram. If you're talking to engineers, process flow diagrams have a lot more equipment and different types of symbols in them. But if we're talking about quality control tools, it's fine to call this a process flow diagram. And this basically shows you how things move through your process, and it will help you identify where in your process things can go wrong. Check sheets are another type of quality tool that we can use to make sure our process is behaving the way we want it. These things are set up so that we can quickly and accurately collect data in different number of categories. These categories may come from a Pareto diagram, or they may be categories of interest. So in this example right here, we have a student who is taking a typing test. And so how the typing test is scored is based on the type of error that she's making. So maybe she reverses letters, or she's got letters missing in the word she types. Every time that happens, we just put a count. You can do a quick tally count like this, and then you have a final count at the end of how many the tallies are, and this will add up to the total number of errors, or in a food process, the total number of defects or problems that's observed. Histograms are one of our last types of quality tools. Basically, what is going on as a histogram is that you put your data in some category. Here we have weights in order from lowest to highest. And so you have the frequency posted on your y-axis right here. So a lot of histograms for food type data are normal, and that means they have a bell-shaped curve like this. You don't see a lot of other types of distributions. The normal distribution just means that it's bell-shaped. In your histogram, in the center, you want to have your optimal weight in this case, or your optimal variable. So you want the center, what it has the highest frequency, to be the optimal. If it's shifted left or right, that means you have a problem with your process. The process capability is the far left end and the far right end of the data in your histogram. That is what your process is capable of producing. The tighter your capability, the better your process is. And so if we say, all right, our process is producing weights from 10 grams to 50 grams, maybe that's good in terms of what we want if our optimal is somewhere in the 25 to 30 gram range. But if our process is producing 10 grams to 200 grams, that's not so good. We want to tighten that down a little bit. And we definitely want to make sure our capability that our process can produce, the range of weights in this case, is within our tolerance. So going back to the first one, let's say it's okay if our weights are between 10 and 50 grams. Our tolerance is outside of that. So our process is producing product that we can use. It's in spec. On the other hand, if our process capability is outside of our tolerance, we're going to be producing product right here that we can't use. We either have to rework that or we have to throw it away. We have to do something with it because it doesn't fit where we want it to be. And we'll talk about what happens to product like that and how you can tell how much product you're producing outside your tolerance limits later on in this course. Our final quality control tool, which we'll also talk about in significant detail later on in this course, is a control chart. And what happens in a control chart is that you post your data, and this data is usually an average as you go through different points in time. So control chart shows you what's happening to your process over time. We'll also talk about how to get these upper and lower control limits later on in the course, but basically you want your data to be between these control limits. Otherwise, something is going wrong with your process and you may be producing data or product that is not good. So to summarize, these are quick descriptions of our different basic quality tools, and we use all of these different quality tools at different times to figure out how is our product doing, how is our process doing, are we producing the level of quality that we want.